Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Well, dear students, let's continue with the next set of questions of combinations. Fifth question: a student has to answer 10 questions, choosing at least 4. All right, so choosing at least 4 from each parts A and B. If there are 6 questions in A and 7 in B, all right, in how many ways can the student choose 10 questions? Understand? So there is a part A, there is a part B. In part A there are 6 questions, part B there are 7 questions. You have to answer 10 questions totally. How many questions are there? You have 13 questions are there at your disposal. You have to answer only 10. All right, you have a choice of 10 out of 13, but those 10 questions have to be selected so that from part A you take at least 4 and from part B also you take at least 4. You cannot take 3 from part A and 7 from part B. You cannot do that. All right, so at least 4 have to be selected. Minimum 4, maximum can be 6 from part A, 7 from part B. That's the maximum limit that you have. All right, so in how many different ways you can do this? Understand? So you have got part A and you have got part B. So in part A you have got 6 questions and in part B you have got totally 7 questions. So now how many questions you can select? You can take 4, minimum 4 you have to select, no? So 4 here and you can take 6 from B. Next you can take 5 here. So how many more you have to select? Totally 10, no? 5. And then you can take 6 at the most. You have got only 6, so you cannot take 7 next. Okay, 6. And if you take 6 from here, you have to take only 4 from here. So at least 4 you should take. Now you cannot write 3 plus 7. You can't do that. 4 is the minimum. Okay. Well, so now 4 from part A, 6 from part B. How many ways you can select 4 from 6 questions? You can take 4 questions from 6 questions in 6C4 ways, correct? So let's write that. Okay, so you can take the first selection. So totally you should have 10 now. So how many ways you can take 4 questions? In 6C4 ways, and you need how many more questions? 6 more from 7. This is from part B. Okay, so part A and part B will give you totally 10 questions. So this is and in between, so therefore it is multiplication. So that is one way of selecting, okay, one way of selecting 10 questions. Or what is the next possibility that you have? 5 and 5. Okay, so that is or in between these two, the different selections. So it is plus. Okay, so or is addition and is multiplication, keep that in mind. Now how many ways you can select 5 from 6? 6C5 and 7C5. Okay, so 5 questions from part B. out of 7 questions, or you can have 6 from part A, so that is like a 6C6 and 4 from 7 of part B, so 7C4. So this is the total ways you can select 10 questions out of 13, taking at least 4 from each part. Okay. Well, now we have to calculate this and get one of these options. So let's do it. Now first you have got 6C4. What is 6C4? 6 factorial divided by 4 factorial, and then 6 minus 4 is 2 factorial into you have 7 C6 is nothing but 7C1, if you know what I mean. Okay, so NCA is nothing but NC n minus A, correct? So NCA is equal to NC n minus A, 7 minus 6. So 7 minus 6 is 1. So 7C1, 7C6 are same. So if you know these shortcut methods, you can calculate these answers quickly. Now 6C5 is nothing but 6C1, right, because of that formula again, and 7C5 is 7C2, but both will give the same answer. Let's calculate that. So this is 5 factorial and 2 factorial plus 6C6, NCN is 1, and then 7 factorial divided by 4, and 7 minus 4 is 3. Okay, so let's continue and see what do we get. Alright, so here this can be written as 6 into 5 into 4 factorial. So 4 factorial gets cancelled, and 2 into 7C1 is 7 plus 6C1 is 6, NC1 is n, alright, and here 7 into 6 and 5 factorial cancels, divided by 2 plus 1 into since it is 1, you don't have to write it. 7 factorial can be written as 7 into 6 into 5 into 4 factorial. 4 factorial can be cancelled. 3 factorial is 3 into 2, which is 6. Okay, so finally this is 6 5 is 30 divided by 2 is 15. 15 into 7, you have got 105, correct? Yes, and then you have got 7 3s are 21, so 21 into 6 126 plus here it's simple thing 35. Alright, so totally 126, 220, I mean you can add it here, so that is 140, 140, 266. Okay, so 266 is the answer, option A. So option A is the answer for 5th question. Alright, so you have to speed up this calculation part, alright, and the first initially also you have to understand how many questions to select from each part. So once you know that, it's only the calculation part that must be done with accuracy. Okay, well, let's move on with the next question. Okay, so question number 6, in how many ways a committee consisting of 3 men and 2 women can be chosen from 7 men and 5 women? Alright, so this is totally number of people available, 7 men and 5 women. How many you have to select? You have to select 3 men and how many 2 women and 2 women. Okay, the word and is very important here. Alright, so multiplication. Okay, now how many ways you can select 3 men from 7? 7 C3 and is multiplication, and out of 5 you have to select, combination is selection. Okay, 2 women. Okay, so just calculate this. This was a straightforward question, direct question. Let's see what we get here. 7 C3, 7 factorial divided by 3 and 4, right, r factorial and n minus r, 7 minus 3 is 4, into 5 C2, 5 factorial, 2 factorial, 5 minus 2 is 3 factorial. So this is like 7, 6 and 5. 4 factorial can be cancelled, 3 into 2 is 6, and then this is like 5 into 4, 3 factorial can be cancelled, divided by 2, so cancel out this, this is 35, and here it is 10, so which is 350. So 350 is the answer, option B. Well, option B is the answer for 6th question. Let's move on with the next question, question number 7. Okay, look at this question, very strange question, a different question. Alright, so before we go into this question, I want to give you one more formula of combination, sum of combinations. Alright, so that is NC0 plus NC1 plus NC2 so on till NCN, if at all you have. The sum of this series is 2 raised to n. Alright, so this is from binomial theorem chapter. So when I do that, I'll explain this formula again. Just remember this formula for time being. Let's start with the question. A crocodile is known to have not more than 68 teeth. Alright, so not more than. So not more than, which is less than or equal to 68. Alright, so maximum it may have 68, okay, not more than 68, but it can have 67, it may have 68 also, okay, not more than 68. 69 it won't have, 68 is the highest number, so it will have 68, equal to 68, or it may have 67, 66, 65 and also on till it may not have any teeth also. Okay, logically speaking, not more than means even 0 is included. Alright, it may have even one tooth, it may have 2 teeth, 3 teeth. Okay, so mathematically speaking, logically speaking, may not be the reality. Okay, we are just speaking about the different possibilities. Now what are we going to find is total number of crocodiles. We are not counting the total number of teeth here. Okay, so total number of crocodiles with different set of teeth. Okay, so there are two meanings for this word set. Alright, one meaning is the set of teeth that you have. Okay, the set, you say, no, the set of teeth. Okay, so if all your teeth are gone, then you put a set of teeth. Okay, so that's one meaning. Another meaning is mathematical set. Alright, so you may have just one teeth, singleton set. Okay, how many crocodiles you may have? Okay, so there can be many crocodiles which have just one teeth. Okay, there can be many crocodiles which has two teeth. All right, so number of teeth I'll take T1 and T2. All right, so this set has two teeth. Okay, there may be another set which another set of crocodiles which has three teeth. All right, so it continues like that. So there are some crocodiles which have T1, T2, T3, totally 68 teeth. Each tooth is different. So that's why we name it T1, T2, T3 till T68. All right. So what is the universal set here, or the total set? I'll just name it as U. Okay, fine. So that has T1, T2, T3 till T68. Different teeth with different size and okay, length and breadth. Okay, so different teeth. So we have given that notation of T1, T2, T3 till T68. Now there may be some crocodiles which has the first kind which has only one teeth. Okay, so it may have T1, it may have T2, it may have T3, it may have T4, correct? So totally how many crocodiles you will get having one tooth? Totally 68 crocodiles, correct? Likewise, you may have two teeth, let us say, as I said that already. So one crocodile has T1 and T2 kind of teeth, another has T1 and T3 kind of teeth. Okay, so likewise, how many different set of teeth possible? All right, how many different set of teeth possible? T1, T2, T1, T3, T1, T4, T1, T5. Likewise, you can start with T2, T2, T3, T2, T4, T2, T5. Likewise. So how are we going to calculate? This is just for 2. You can have 3. Okay, you can have 4. Then you have all the combinations of that. So this is basically combinations. So how are you going to calculate that? First, you may have a crocodile with no teeth at all. That is nothing but 68 C0. What is NC0? 1. So how many crocodiles are there? Only 1. And how many crocodiles with one tooth? 68. Out of 68, you have to select one, anyone. You can take T1, you can take T2, you can take T3. Singleton sets, how many possible? 68 C1. Out of 68, you have to select one at a time to form the singleton set. Okay, anyone. So I mean totally 68 possible. Right, so NC1 is N, 68 C1 is 68. Next, how many different crocodiles possible? How many different crocodiles possible with 2 teeth? Right, so out of 68 different teeth, you have to take 2 at a time. Correct. So basically, we are calculating the subsets of this. Okay, so this is a subset in which you have 2 elements. So out of 68, you have to take 2 at a time. So any 2. Okay, so just for an example, T2 and T5. This is one example of this. All right. So you can take any 2 at a time. Now, what is the number of crocodiles having 3 teeth? So that is 68C3. Next is 68C4. 4 different. You have to take 4 different out of 68 teeth at a time. Okay, so one crocodile you take that may have 4 teeth. Which 4? Any 4. So likewise another crocodile 4 teeth, but different 4 teeth. Correct. So how many different possible? 68C4. if you are going for 4, then 5, then 6, then 7, ultimately 68, C 68. So it's not even practical to write all of this. Okay, don't write all of this, it's foolishness to write. Okay, you can't just solve it manually, you have a formula for that. So if you have NC0, NC1, NC2 till NCN, the answer is 2 to the power n. Now what is the answer of this? This is 2 to the power, what is n? 68. So this is 2 to the power 68, which can be written as, I mean, you don't have that in the options, the only possible option is this. Okay, that cannot be attained. Anyway, so I'll write the 68 as 4 into 17, correct? So 34 plus 34, 68. Now I'll split this, I'll write 2 to the power 4 and to the power 17. Basically 4 into 17 is multiplied, correct? And now what is 2 to the power 4? 16. So 16 to the power 17. So that's option C, and option C is the answer for this question number 7. So this is basically calculating the total number of subsets if the given set has 68 elements. So this is the total number of subsets, 2 to the power 68. Alright, so you don't even have to write this, you know the formula from the chapter of set theory. Okay, so if you have 68 elements in the set, what is the total number of subsets? 2 to the power 68. Alright, so but if you want to split that and try to understand why you should have 2 to the power 68. See how many subsets with no element? Just one subset, 68C 0. So you have to select 0 at a time. To get a subset of one element, singleton sets, you have to select 1 out of 68. So 2 out of 68. When you calculate the total, it is 2 to the power 68. Anyway, so that's it about question number 7. Let's move on with the next set of questions.
Don't forget to like our video and subscribe our YouTube channel for all the updates.